Now let's deep dive into more Git commands and more Git architecture. So the main principle of Git. So once you understand the main principle of Git, it is astonishingly simple. So first, Git handles the content in snapshots, one for each commit, and knows how to apply or roll back the change sets between two snapshots. This is an important concept in my opinion. So this is the real basic principle of Git. Anything else follows from this. So let's delve into Git a bit further. So let's begin with working with Git in a local repository. No remote repository, only local repository. So this is current working folder. I will show that. So as you can see on the screen, I will create the current working folder or current working directory. Okay, the folder name I'll create, and then so let's create our current working directory or current working folder. So new, so the name of the current, okay, I'll put current working directory. So we have created our current working directory, and this is that current working directory. Okay, so that's clear. So the first one is clear, current working directory, and that consists of number of folders, files. You can have a subfolder and sub files and lot of data in it. So as we have created our current working directory or current working folder, so now you need to run the git init command. So when you run a git init command, it turns your current working directory into git working directory and creates the repository in the .git hidden directory. So this is what's going to happen. That's it. So I'll keep this at this moment where we have only created current working directory. So let me enter into the current working directory and then open the git bash in this directory and make it zoom it and bring it here. I'll keep it on left side so that it will be clear. Yeah. So now let me click on ls pwd. So we are in current working directory. You can see the visual representation of the same on the screen. Okay, here. So now I will create one file, 3 to 4 files I'll create. Touch file 124.txt, and then folders I'll create mkdir folder 1, 2, 3. You see, now you have 4 files and 3 folders. So for now, okay, let me enter into folder 1. Let me enter into the folder 1. Nothing is there inside that. I'll create 2 more files. Says touch file 11 to 12.txt. Yes, and similarly, I'll create in folder 2 also cd folder. So touch file 21 23.txt. Yes, so okay, rm rf again. Yeah, so we have, let me get back into this. Yes, so now our current working directory consists of 4 files and 3 folders, which is similar to the representation, visual representation in our screen. So let me take you to that working directory. You see, our working directory consists of 4 files and 3 folders. This is what is our working directory. So at this moment, let me take this. Yeah. Mm, yeah. So let me clear the screen first. Now ls I do option a. Now you can see only in this directory you have 4 files and then 3 folders, nothing else. Now what we are going to do is, let's do git initialization. Like we have done terraform initialization, we have done the packer initialization. Similar to that, we are going to do git initialization. What happens when you do the git initialization? When you do the git init command, when you use the git init command, it turns the current directory into the git working directory and creates the repository in the .git directory. Here it is. So if you see the animation, current working directory has become a git working directory, and it will create one more directory inside that, that is .git, and then it will create a local repository at the same time in the .git. Okay, so we will create it, we'll apply the same command, and we'll see what's going to happen, what magic is going to happen. I'm giving, so git init, so initialized a empty git repository in this directory, in this path. So now let me check ls. Yeah, that's it, the magic happened. If you see here, just few seconds before lsa there is no .git. After the git initialization you see the .git hidden file. That's the same magic we have shown on in animation form. So now let us go into the .git and see what is there. So cd .git, this is actually git working directory. So now let me do ls. So it consists of a head, config and description, 3 files, and it consists of hooks, info objects and refs directories. Let me head cat head. Okay, got it. So it consists of it is referring to the master, and heads are referring to the master. Then we have config, cat config. So config consists of this core information. Then we have description file, description. So description has a unnamed repository. You can edit this. Then we will enter into git hook. Sorry, cd hooks. So it consists of a number of hook files. So number of hook files. It consists of a number of hook files. So what is this hook file will do? So the hook file do cat, and then I'll take commit message. I'll take hook file. So what it is saying, this hook file, an example hook script to check the commit log message called by the git commit with one argument. That's the name of the file. So if you want to enable this hook file, rename this file to commit message. So you just rename it, then this hook file can be enabled, and you can use this command. You can use this commit as a commit message. I think it's commit message as a command. So and it consists of they have given some examples. So this example catches duplicate signed off by lines. You can add any some amount of script here so that when you call that command, it's going to execute some kind of activities. Okay, so and we have info cd info. This consists of some folders and we have cd objects. It consists of info and pack same, and then finally we have cd refs. So this consists of heads and tags. Whatever tags you create, all will be presented in this. Let me go to the tags at this moment. So there are no tags. There are no tags. We have just initialized the git directory. So that's why there are no tags. And then let me get back and see the heads. There are no heads. So this is the present condition. This is the present condition. These are the files that are presented inside the .git, or we call it as a git directory. It's called a git directory or git working directory. So the present working, the current working directory has become a git working directory. At the same time, it's going to create a local repository. That's what a git init will do. Of course, I know it's a detailed explanation, but I hope it helps you. So that's the reason I'm giving the detailed explanation with practical demonstration. So now, what's next? So the focus on the change set is the reason why in git you have the add command similar to svn. So with this command, a change in the working directory is added to the staging area for the next commit. This staging area is usually called the index. Index. If you see on the screen, let me do this animation one more time. So it's getting started, and git add, when I give git add, the staging area will be created. What is this staging area? Where will it be created? Is this the magical? Where will it be? Is it this, will it be visible? You might have all these questions. I'm going to show you. Okay, so let's get into our directory and first clear the screen. So what I will do is I will say git add, and then I will add only one file, that is file file one. Okay, where I am? Okay, I'm in a wrong place. Yeah, this is the correct one. So I do git add and I say file one.txt. I want to add only one file. Now when I say git add, where will this file be added? That's my question. Do you know? Does anybody know here? I'm asking you. If you know, you just post this in comment section. So when we say git add, where will it be added? Let's see. Let's see why to answer. I'll say. So git add, the file has been added, but where will it be added? So here in theory we said the staging area, but where will that staging area be presented? Where will that staging area be presented? So I'll show you that. So now let me get into cd.git. You see, clear the screen first. Again, I'll do ls. Here it is, the index. You see that? Index. And here is the staging area. And the staging area will be created inside the .git directory or git working directory. Okay, so now let me cat the index file. Here is that file one.txt. It's that visible, it's that simple. Okay, so whenever you say git add, that will be added to a staging area. In that staging area it will be located. It won't be added to some delusory place or area or directory or folder. No, nothing. There is a concrete index file is there. In that file it's going to be added, because these are all changes. All these changes will be added. in that file. Okay, so now let me get back to the our main working directory, current working directory. So I will add one more file, git add. This time I will add folder 1. Folder has been added. Let's again get into .git and then clear the screen. ls cat index, sorry, cat index. Here it is, folder 1, folder 1, and then inside that folder file1.txt, and then inside that folder one file 12.txt. So file 11.txt and file 12.txt, everything has been added to the staging area. I think you're getting my point, or do I need to explain more? Kindly, if you have any more doubts, please ping me on comment section. I will clear off your all the doubts. So let me clear the screen now and get back to the git, get back to the working directory, and I will now say git add all. All means all, everything. So I have added everything. So now get into this place and then do cat index. Where I am? I'm in the wrong place. Okay. Yes, I came out completely. It is current working directory and then cd dot git. So now I will do cat index. Sorry, cat index. Here it is. Almost all files have been added. File 1.txt, file 2, file 1, file 2, file 3, then folder 1, file 11, folder 2, file 21, and folder 2, file 22, and folder 2 is here, and one more file, file 11 is here, and file 12, folder 1, file 12. So all files that our current working directory. So this is my current working directory. This is my current working directory, but here I cannot see because that .git folder is in, it's hidden. So that's hidden. So you have to change the settings and show hidden files, then you can see that, and inside that you can enter into the cat file also. But this is my current working directory, and this all these files have been added into this staging file or index file. We call that area, this file, we call it as a staging area, or we can call it as an index, whichever the one is better. So then we have yes, you see the animation, the file 1 has been pushed into the staging area. So file means it's not exactly file will be pushed, whatever the change that you have done, so it's related to the file, so the file will be added to that index file. Okay, so then file 2 will be added, file 3 will be added, and the initial state is A. Then after that, after adding these file states is B. So now it will take the snapshot when there was no file, and it takes the snapshot when 3 files have been added, and the difference it will note down. It will note down the difference. It will write it as A to B. So then we have once you have added this to the staging area or index, now you have to commit these changes, whatever changes you have done, in a simplest way, saving these changes, or else you have done the changes but you have to save these changes, you have to keep it alive. For that you have to save a change set from the working directory into the repository. So this staging, so for that we have to give git commit, and then m option means whatever I'm typing ahead is a message, it's a argument, that's what it says. Once you commit, then all these files will be stored as a snapshots in local repository. Okay, and you can see that this is snapshot content A, snapshot A, this is snapshot B. You can easily make out the difference the same way I have done with my, yeah, here I have done na snapshot A, snapshot B, snapshot C. I can tell the difference between snapshot A and snapshot B. The same way it will create a local repository, and inside that it's going to create that snapshot A and snapshot B. Now let's do the commit. We are committing to the local repository only. Okay, so let me clear the screen, get back to the current working directory. Yes, we have all the files. Now I'll say git commit and m option, then I'll type this is the commit message to understand the functioning of commit. So the commit has been made. What it is saying, master, that's the branch name, and then root commit. So this is the ID or snapshot ID. So this is the commit message. We have typed the commit message, and after that, how many files changed? 9 files have been changed. 0 insertions and 0 deletions. Only the files has been changed. Okay, this is what had happened. Now, before we do anything else, get into let's get into cd git, and now you see, let me clear the screen first. ls commit edit message has been created. So if we cat the commit edit message, you see that this is the commit message to understand the function. Whatever commit message that I have given, that will be reflected there. Then let's get into cd refs, because cd tags, cd heads. Yes, master is the head. Before there was no head, so now the master head has come. So cat, yes, this is the id, this is the id of that master. So let me get back. So now let me look into hooks. cd info, cd objects. You see that all this, let me get into cd23. You see the code. Now let's read cat config file. Then again let's check cat head, master again, cat, then description we haven't changed anything. So let's read index now. Now you see, so all the folders, by and large, everything has been put into this, and it's been committed also. Okay, so we have covered all. So hooks we have seen, infos, log, yes, log, we forgot the logs. Logs we forgot. ls, we have head, and then refs. Head we know, we look into refs. Inside that we have heads, master. Okay, sorry. Yes, this is what I want to show you. No. So what had happened? Okay, I'll make it bigger and I'll show it. Yeah, now it's fine. Same command, cd master and cat master. Yeah, here. So complete id, unique id snapshot, and then these guys, and at this time commit. This is the initial message. It's the complete information about the snapshot, what had happened, how it had taken. CD, get back to the working directory. No, no, still we are there. Still we are there. Still we are there. Yeah, now we are into master. Okay, so that's what happens. And so just to summarize whatever we have seen so far, we will have a git working, sorry, current working directory. That is this. This is our current working directory. When you initialize git, then it will become a git working directory, that is .git. So that's our git working directory. Then when you want to add these files, when you say git add the files which are present inside the current working directory, then it will create a staging area or index file, and these files will be added into that index file. And once it is added into the index file, then if you want to commit these changes, if you want to save these changes, like what happens when in while you are working on MS Word, after adding 3 or 4 lines, you would like to save that. You would say control S and you will save that file. Similarly, whatever changes you are doing to your staging area, those you want to change it permanently, you want to save it permanently. For that reason, we have to commit it. Once you commit this, all the information, whatever changes you have done, all will be taken as a snapshot. So before commit and after commit, before commit one snapshot and after commit one snapshot, and that will be put it in local repository like this. Okay, so whatever activities that we are doing, that are not happening in current working directory. If you think all these commands are being executed in this directory, no, they are being executed in hidden directories, but they exist, but they are not visible for you. You have to use ls option a command to see them. So before conclude, I would like to tell one more thing, that frequently you will get this kind of message: capital C, capital R, space, capital L, capital F. This is for Windows, and LF for Unix. So and CR for Macintosh. So when you see, okay, this is not compatible with Linux, and Linux, this whatever code, whatever data that you have is not compatible with the Linux type. So this kind of messages you will get. So you will just understand what is the difference between CRLF and LF and CR. Okay, CRLF is specifically for Windows, LF is for Unix, CR is for Macintosh. So these are, what do we call this? These are all line break types. So CR and LF are control characters, respectively coded 0x0D. So it's a 13 decimal and 0x08 10 decimal. They are used to mark a line break in a text file. As you indicated, Windows uses two characters, the CR LF sequencer. Unix only uses LF, only LF, and the old Mac OS uses CR. So CR means basically carries a return, and LF means a line feed. These are two different types of basically typewriting. So CR and LF, so two expressions have their roots in the old typewriter or TTV terminal. LF, what it does is, LF means a line feed. Na? LF moved the paper up directly, but kept the original position identical. I think you are getting my point. I don't need to explain this. LF is a line feed. Line feed. You will have your pointer constant, paper will move up. That's called line feed. So LF moved the paper up but kept the original position identical. And CR, that's a carrier's return, brought back the carriers so that next character typed would be at the leftmost position on the paper. but on the same line. So whereas CR plus LF was doing both. So Windows will have both CR plus LF, that is carriers return and line feed, whereas Unix and Linux will have LF, that's a line feed, whereas Macintosh has CR only. So these are different ways to preparing for a new line, waiting for the new data to be entered.